We're going to finish this series with running through one more full example. We're going to take a look at the employee class, and we're going to write some new classes that represent specific kind of employees, specifically employees that get paid, some that get paid by an hourly rate and some that get paid by a salaried rate, and then also employees that are unpaid. So you could think about, for example, an intern might be considered an unpaid employee. So let's take a look at the employee class. So recall that our employee class, employees were described by a name, ID, and phone number, and then also they have a variable of type status that was an enum, and the options for status are full-time, part-time, or inactive. Now I've created a constant here, default status, and I've decided that in addition I have this default phone number we can use for employees. That's the kind of the company line. Perhaps we also want to have a default status saying that, most of our employees are full-time. So if you don't provide a status for me, I'm going to use that as the default. This would allow us, looking at our constructors, add a third constructor. So we previously had two constructors, one where you created an employee based on the name, ID, phone, and status. So basically sending in all the information. Then we had another constructor where we only send in the name, ID, and status, and we use that default company phone as the value for phone. So we invoke this constructor, sending in the default value for phone. But now I've added an additional constructor where all you have to send in to create the employee is the name and the ID, and then we use that default phone number and the default status to invoke, again, this first constructor. Okay, so we now have three constructors, three different ways to set up employee objects by sending in varying combinations and amounts of the information about the employee and using those default values when the information is not passed in as a parameter. So that's my instance data variables, my constructors. I had my getters and setters. I had a toString that just outputs the name with the ID in parentheses. And then I had three class-specific methods, a pay method, which right now is just a print line saying we're paying the employee, a review method, which is just a print line saying we're conducting a review of the employee, and then I had a benefits method that said if the employee was either full-time or part-time, then we're processing benefits, but if the employee is inactive, that employee does not receive benefits. Okay, so these are my kind of class-specific methods. And then, of course, I've just added my equals method to be able to compare two employee objects. So this is my employee class. Now, I'm going to add some child classes to represent specific kind of employees. So I'm going to start out with a paid employee. I'm also going to have the more specific salaried paid employee. The also more specific hourly paid employee, and the sad unpaid employee whose only benefit is experience. Okay, so the very first thing I want to make sure is that I'm following good design with inheritance, meaning that I have that is a relationship, and I do, right? A paid employee is an employee, they're just a specific kind. A salaried paid employee is an employee, they're just a specific kind. Same with an hourly paid employee, and same with an unpaid employee. Okay, so now I could just go ahead and add in the instance data variables that describe each of my different kinds of child classes. So let's start with salaried paid employee. Well, first remember that a salaried paid employee is described by a name, ID, phone, and status because salaried employee extends employee. So a salaried paid employee is an employee, so they inherit all of this information from employee. Okay. So I have all that stuff that describes my employee, but now I probably also want to add information about the salary. So I will add instance data variable to represent the salary of this employee. Okay. You could also have, instance data variable to represent a bonus if maybe your salaried employees earn a bonus or something like that. So that's my instance data variable. Now I'm going to have my constructor. And remember, for my constructor, I need to take in all the information that describes a salaried employee, including the name, the ID, the phone, the status, and the salary. So I need to take in all the information, including the instance data variables that are declared in the parent class. Now, unless I say, I only want to take in the the name and the ID, and I'm going to always use the company phone or the default status, you would have that option of doing that as well. But I'm just going to take in all the information. So the name, the ID, the status, and then of course our salary. And then I'll use the call to super to invoke my parent constructor. Say, hey, parent class, you set up your part of the object. So set up the employee characteristics, right? And I'll send in the name, the ID, the phone, and the status. And then I'll say, okay, and now I'm going to update the child part of the object by saying this.salary is salary. So there's my instance data variable. There's my constructor. And of course, I could choose to override this constructor and include a version where you only take in, let's say, the name, the ID, and the salary. And again, you'd have some different options of how you implement that. One would be to invoke the overloaded constructor in your child class, sending in the name, ID, the phone, and then the employee.default, the name, the ID, the employee.default phone, which I have to make sure is public if I want to be able to access it. It is. Okay, that's good. The employee.default status, and then the salary. So this invokes, what am I missing here? Default, it's called company phone. So this invokes this salaried paid employee constructor. I actually prefer this design where you invoke this. I think this is good because it allows you to avoid that repeated code, but you wouldn't be able to do this if these constants in the parent class are not declared as public. And also some people prefer the other way because they think, well, this is really sort of relying on the child class to determine which parent constructor to invoke when, really that should be up to the parent class to say, if you only give me these two pieces of information, it should be the 2-parameter parent constructor. So there's arguments on both sides. You'll see both in code, and you can use both in your code as well when you have that option. Again, if these weren't public, you wouldn't have the option, and you'd have to invoke super with name and ID, followed then by this.salary get salary. So you'd have to do that if those constants weren't public. Okay, so there's my instance data variables, my constructors. Next up is my getters and setters. Now remember that I am not going to override my getters and setters from my parent class, so I don't need to override the getters and setters for name, ID, phone, or status because I inherit them from my parent class. I don't need to rewrite them. For my salary, I'm going to include some validity checking. So I want to make sure that the salary is at least 0 before I update that value. Okay, so there's my getters and setters. So now I come to my toString method. So I have to think about whether I want to override the toString method that I inherit from employee. So right now I inherit this version, right? This is the employee version, which has been overridden from object, and it prints out an employee's name and ID. So I have to think about, do I just want to inherit and use that version, or do I want to totally change the output, or do I want to do the parent's version of the output and then add a little more? As is common with toString, I'm going to choose to do the parent's version and then add a little more. So I'm going to say string s get super.toString. That'll invoke the parent version, the employee version of toString, and I'm just going to add on to that maybe the salary information. Okay. So now thinking about my other methods, I have my equals method. That's my 5th core component. So now I want to say, do I need to override the equals method? Well, right now, my equals method set that I inherited says if my salaried paid employee has the same name, ID, phone, and status as another salaried paid employee, then they're equal. And if any one of those things are different, then they're not. So I'd have to think about whether it makes sense to override this or not. Now, if I say, really, no, if these 4 things are equal, then these 2 employees are equal, then I don't need to override it. I can just inherit the version from employee. If I wanted to add information about the salary to my equals, then I could do that like this. So I'm going to have my same start as I always do. My instance of and my cast. And then I could return super.equals, right? So this is going to invoke the parent version of super, so the one in employee. So that's saying, hey, make sure all the employee parts of the object are equal to each other. And then add on also that I need this dot salary to be equal to other employee dot salary. And of course, if you don't send me a salaried employee, I'm just going to return false. Okay, so if you do decide to override equals in a child class, you can again use that super dot to be able to reference the parent version. Okay, so let's look at my other methods that I have here. I had a pay method, a review method, and a benefits method. So for the pay method, I have to decide if I want to overwrite this, and probably I do. Override this. And probably I do. I want to override public void pay because I'm going to be specific now because I know I'm paying this employee by salary. So here I'm going to, paying, let's say they get paid every week, 1 out of 52, or let's just say salary divided by 52. Okay, something like that. So here I'm saying I'm really doing something different in this version of pay, in the child version of pay, and if that's the case, then I want to totally override it. I want to replace the parent version of the method. So notice I don't invoke super.pay. If I decided I wanted to do the parent's version and then just add on the information about salary, I would just invoke super.pay and then add more on. Now when I look at review, do I need to change a review? Well, are salaried paid employees reviewed any differently? Perhaps not. If that's the case, then I just inherit that version. I don't override it. Are salaried paid employees treated any differently in terms of benefits? Well, maybe not. If that's the case, again, I just inherit that method. I don't override it. So it's again, this is the idea of why inheritance is so powerful, because we get to take this code and push it high up into employee, and now I don't have to rewrite it inside of salaried paid employee. I can just use it. Okay. Okay. So we're going to do something similar with our hourly paid employee. And I'm going to pause the video, put the code in a minute, and then pick back up and we'll go over it. Okay, so here we have the code for our hourly paid employee. So here, just like I did with salary paid employee, I extended employee. I added instance data variable to represent the hourly rate, representing that as a double. I also included a constant. Perhaps this is like the minimum wage, the default hourly rate. So if you don't specify a rate for an employee, this could be the rate you'd use. I have one constructor that takes in all the information, so that includes the instance data variables inherited from the parent, as well as the new instance data variables described from the child, and then we call the parent constructor to update the parent's part. Then we add on code to update the child's part. I have two other constructors that allow you to create an hourly paid employee with less information by using those defaults for company phone, status, and hourly rate. I've got my setter and getter only for hourly rate. I overrode my toString method, and I again used the parent version and then added on some additional information, namely the rate. And then I overrode the pay method to say, okay, well actually for this I'm paying at an hourly rate of whatever the rate is. So that's my other child class. Then finally I've got my unpaid employee child class. This also extends employee, and here I didn't add in any additional instance data variables. So sometimes it's the case that your child classes won't have additional characteristics that describe them, but they do represent a more specific kind of object. So it's still a good idea to write a child class even if you don't have additional characteristics to use to describe those objects. So for an unpaid employee, I'm just going to take in the name and the ID and then invoke the employee constructor with that information. And then here I chose to override all three methods, pay, review, and benefits, to specify that this employee is not paid, that they don't really get reviewed. Maybe they just do a review that they send back to their college, and they don't receive benefits. So in salaried paid employee and hourly paid employee, I didn't override the review and benefits method because the parent version still made sense. But for unpaid employee, the parent version does not make sense, so I do choose to override it in the child class. So there's an example of taking our parent class, writing child classes to inherit all that stuff from the parent, overriding what makes sense, using the parent version of that method when we want to just add on to it, or completely replacing it when we want our child method to do something totally different. Now, I didn't put any code inside this paid employee. I'm going to leave this as a placeholder. We're going to return to this when we talk about abstract classes, which is coming up in a future lecture series. I wanted to just put this in there for now to just get you thinking about that and get you thinking about, is there anything in the salaried paid employee and hourly paid employee that's sort of duplicated code that we could push up one level in the chain and actually have hourly paid employee extend paid employee, and then paid employee would extend employee. Okay, so we can sort of add another level in there of our parent class. We're not going to do that yet. Just put that in there again to sort of get you thinking about that. But for now, we're just going to use these child classes of the salaried paid employee, hourly paid employee, and the unpaid employee. And we could have a driver program that creates objects of all these types. So you have all these types. You can invoke your various constructors. So for example, in hourly, we can invoke one constructor that takes in the 3 pieces of information, another that only takes in the 2 and uses that default rate for the hourly rate. So here's some examples of creating those objects. All right. So hopefully this example helps bring it all together, all of these concepts that we are learning about inheritance.